Okay, as mentioned earlier, troubleshooting is hard to teach. Usually it's best when you're out in the field and you're working through stuff, trying to figure stuff out. That's the way you learn. So let's go over a couple of troubleshooting ones real quick and see if they make sense. Fuses procedure to use a multimeter. We just saw the video on that, and I just want to remind you the first thing you want to do is you want to check for voltage, okay? And then if you're going to use the procedure to check a fuse, in our case we have two fuses right next to each other. So you're just going to start here and here, and if you have voltage between them and you're working this way, if you're working forward, you just move to the next spot. And if you have voltage between here, you had voltage here and you still have voltage here, well then guess what? That fuse is good. Now when you move forward again, if you don't have voltage there but you did here, well then I'm guessing that you have a bad fuse there. So you can switch the locations to front to back to front, and then that will help you determine the procedure for checking whether the fuse is good or not. If it's a single fuse, you just move it forward and you check against your neutral as you move forward, trying to get voltage here and voltage there. Loose connections with a screw terminal. This is a big problem, and it's one that's easily fixed. So if you take a look at this Allen Bradley equipment, they've got the screw terminals here. These are industrial. When you put a wire in there, you can absolutely crank down that screw super tight, and you should, because you do not want it coming out. So when you have a loose terminal or a loose screw, loose terminal, it could fall out, it could be jiggling off and on, and it might not be working. So loose terminals is a big one. Tighten those babies down. Pinch insulation. That's a big one. So what you have here is, I don't know if you can see it or not, but on this wire right here, there's a little indentation on the insulation. Well, that's because you see copper here, but you don't see enough. You don't see enough copper there. So when this gets put into here, it gets pushed in there, and then when this gets tightened down, the terminal is actually pinching on the insulation here instead of the copper. And this is hard to find because it looks like it is where it should be, okay? But really you can't find it because it's pinching on the plastic. So the way that you would do this is you would take this and you would strip it out to be sure that there's enough copper being shown there. And a good way to do it, and once again you get a feel for it, is you just slide that in there until you can feel the rubber hit hard against the screw terminal there, if that makes sense. And then if you want to back it off just a little bit so there's some copper, you can, and then you would tighten it. But if you go too far, then you're in trouble because you're going to pinch the insulation in. Okay, so that's a big one, and that's something that you learn over time of how to strip these wires and get them connected correctly. Okay. Faulty contact, a relay or push button. Oh, this can just drive you crazy. So basically, you see it on the push button here, when this closes, you see the contacts closing. And it looks like they're closing. But just because it looks like it's closing doesn't mean that it is, okay? So you might have to isolate this and put a multimeter on there and figure out that, hey, are these really closing? Because if they're pitted or there's not enough force on there, they might actually not be closing, okay? So that's a big one. Faulty contacts on the relay or push button. Incorrect wire markers. Well, so a wire, every wire, let's say this was a wire here. This would be, let's say, a number 2 wire. I would expect a 2 on this end and a 2 on this end, okay? This wire right here, just because of the color of it, tells me that it should be DC negative, okay? So if for some reason the wrong color wire or the wrong wire number is used, or if this had a 2 on one end and a 3 on the other, woo, that's going to be complicated because this is all one wire. It should have a 2 and a 2 on it, okay? So that's really a bummer if you have incorrect wire colors or markings. Solenoid problems due to low pressure or burnout. So you're going to work with a lot of solenoids here, and we'll start working with solenoids. So if there's not enough supply pressure on here, then if it's a air piloted valve, it might not work the way that you want it to work. So you got to be sure that you have incoming air pressure. But these coils could fatigue, and the valve spool in here could fatigue. So these valves could be hard to troubleshoot. So you might have to go to the manufacturer's site and see what the specification was for testing these with your multimeter when they're not installed. And you might be able to test this and find out that you have a bad coil. Okay, a lot of times when you are having a lot of valve problems, it's because you have some damage in there and it's just not working right. And a lot of times on these valves, you just throw them away and get a new one. Or if it's a big valve and you can just pop off the solenoid here, or here on the end, you would pop that off and replace that coil, and then bang, you're back in business. Depends on how big it is and how complicated the installation is on that. So troubleshooting valves is a great thing. Low voltage. So we already calculated the load of the contactor and the light, and we demonstrated that. But that's the big thing. You know, if you have low voltage on your device and it's not working like it should, you got to find out why. If it's a 115 or 120 volt device and you're only getting 75 or 80 volts, you got a problem. Or if it's a DC device and it's 24 volts and you're getting 18, it's a problem. So low voltage, and we talked about procedures of moving forward or backwards. Grounds with solenoids, limit switches, and pressure switches. So I use the 2 power supply. If you have a ground, or if you have some connection issues with the limit switches where you mix up the leads, you're going to have a problem. And here's an example. I have 2 different contact blocks here, and so that, you know, you certainly wouldn't mess these up, would you? Because they're different colors. But basically, these terminals are where wires would run into here. Okay, but if these were all the same color and they were all symmetrical, you see here there's metal on this and there's plastic there. So when these go together, they insulate. But if it's the same color and they're symmetrical, sometimes they get put together like this, where the metal here is touching the metal there. Okay, and if they're, like I said, they're the same color and they're supposed to be different signals, or maybe one has a load on it and the other doesn't. When these 2 metal items here touch, well then, you know, you've got a problem. One of the severe ones I saw was where, for some reason, this one had 120 VAC in it, and this one was carrying the DC circuit, and there wasn't an insulator, and they got popped together like that. So the devices were reading 90 volts DC. Well, you can't really get 90 volts DC. Usually DC is 24 volts, and usually the controlled AC would be 120 volts AC. So it took a long time to track that down with a multimeter, and the same method that you just learned a minute ago, to find out that, hey, these were actually touching like that, and we were getting a 90 volt DC reading, which is not safe. Okay. Grounds with pulling conductors. So if you ever have to pull conductors a long ways, and you're not careful and there's sharp edges, you just want to be sure that you don't strip the insulation on the conductors and you expose that insulation, or you expose the conductors to the ground, because then you're going to have a short, and or it might not be enough to pop a fuse or anything, but it certainly could create a low voltage situation. So be careful when you're pulling conductors. Ground to loose strands. So here's a good one. So I have some stranded wire here, and it's pretty fine, but if I were to come in here and maybe break off one strand, okay, so I've just got one little strand broke off right there. Okay, now what happens sometimes is you've got that one strand and you can't see it, and then this goes and it gets plugged into the relay like that. Okay, but right below that, this terminal, there's another little terminal, and this one strand is making contact with the one terminal right below it. So it's not only making contact with the top terminal like it's supposed to, but it's making one strand is making contact with that second terminal. Well, that's going to possibly really mess things up, because that one strand could carry a small amount of voltage or small amount of current, and it could really mess up your system. So you got to be careful with getting something stray like that. Also, if people aren't paying attention, you get one stray and you'll go in this way and you'll accidentally get that one strand touching 2 terminals instead of just 1. So be careful with these trays. Be sure everything gets twisted and tight. And this is probably too long for this anyways. That's quite a bit of copper being exposed right there. You wouldn't want that much copper exposed because that's going to cause a problem. Okay. Poor housekeeping. So poor housekeeping is a big problem. What that means is that you just got wires all over the place. You know, they're not wrapped, they're not wired, they're not AC and DC are all grouped together. You know, it might work, but it's just a big mess. So when it comes time to fix something, you can't find what's going on, and you might accidentally fix something that's not broken, or you might break something that's actually working. So be sure to clean everything up. It gets run in Panda, it gets orderly. Opens in a common. So opens in a common is a pretty easy one to figure out. So the way that works is if you had a ladder logic and you had a light or a push button turning on a light, turning on a bunch of lights here, right? And all these lights were then common back to the neutral here. So this was line 1, this was my neutral line 2. If for some reason you had a break in the common here, because these lights here are daisy chained together, they're sharing a common white wire here, because no use running a white wire and a white wire and a white wire and a white wire. That's way too many white wires. If you lose the common right here, then all of a sudden all these lights downstream don't work. And that happens, you know, it's say, hey, all these lights were just working now and none of them are, or only the first 2 are and none of these are. That's a good situation where you looks like you might have lost your common, and if you can easily find that common, you're all set. Another way to do that is you could just take at the bottom of these lights, if you have a bunch of them, you could just wrap this back to L1 as well, and it would still work. You would have a neutral on one end of the string and a neutral on the other end of the string, and if you lost it in the middle, it would still work. Okay. We have the way to use your DMM, and the big thing is the continuity versus the voltage. So you just want to remember, if you're trying to figure out if this relay is good or not, if this relay works, okay, well, you're going to come and you're going to look at the coil. You want to figure out if this light's going to work. You want to come and you want to check the load. So a lot of people have a tendency to put it on continuity right here. So I put on continuity and I check, and that's fine, and I plug it into the light. You just beep for a minute, but now it's not beeping, so they think, oh, there's no beep, that must mean it's bad. No, we already checked that the resistance of this light was very high. So if I go to resistance, we're reading, you know, about 1200 ohms on this light, okay, but it doesn't beep. This meter, depending on what type of meter, it might only beep up to 100 ohms or 200 ohms, etc. So you're not getting any tone on that. Versus if you take this relay, which we had already calculated was about 70 ohms, and we plug it into the coil, it's beeping. Okay, well, that's great. But if this coil was shorted, we would expect it to beep as well. When you're going to check a load, you are going to check for resistance. Okay, and then you would find that about that 79 or 80 ohms that we had talked about before. So remember, continuity is checking to be sure something's true, and ohms is checking to see if it's a load. Okay, so if you're going to check this push button, for example, you wouldn't want to set it to ohms. You would want to set it to continuity, and then you could set it on the push button here. Let's see if I can even do it. And then when I push the button, it would beep. Okay, ohms isn't going to give me the answer that I want there. So there's just a couple of troubleshooting techniques to help you out.